Hey, what is up, ladies and gentlemen? Guys, look at what's going on here. So this is what we're going to be looking at. This is what we call algebraic, right? Algebraic expressions. Yeah, I know some people be like, but this is way too easy. But hey, in my opinion and from my experience, in doing mathematics and all that, this is actually the most important thing, right? That's like the most important sections in algebra. In other words, if you've got if you're just getting started with mathematics, or maybe you hijack mathematics, make sure that you go back and understand these kind of things, especially for those of you that are struggling with paper one. Just know that you probably got issues with your with algebra, right? So if you can simplify this problem like successfully, then you won't have too many issues there by question one of paper one, because it's mostly algebra. You get what I'm saying? Mostly it's algebra. So what I'm going to do is I'm just going to try and take you through how to solve these type of problems, okay? Right. So let's go for it. Let's go for it. So, okay, what's the first thing that you need to do? So obviously what needs to happen here is that you need to be thinking, okay, to simplify, I need to cancel out terms, right? I've seen with most people, they do know that, okay, at some point we're going to have to cancel, but they don't know at what point, right? So they just see x squared, then they start canceling, right? Whereas what they don't know is there's actually conditions that need to be met in order for us to actually start, canceling things out. You get what I'm saying? That's very, very important. So certain conditions need to be met, right? Now the question is, what conditions need to be met in order for us to start canceling, right? In order for you to cancel anything that is in the numerator and whatever that's in the denominator, you need to have one term over one term. Okay? You need to have one term, right? One term divided by one term. Divided by one term. So meaning that we're gonna go, fraction by fraction, trying to turn everything to become what? One term over one term. Okay, so let's try that quickly. And really the thing that we're going to be using as a tool to turn these expressions here into one term, that's factorization. Factorization. Right? And currently if you check, this is not one term. X squared minus x minus 6. So whenever you say minus or plus, then you're moving on to the next term, right? X squared, that's the first term, minus x, that's the second term, minus 6, that's the third term. So whenever you call out the operation plus or minus, that means there's another term following it, right? There's another term that is coming. But if you say, for instance, x times y, you are saying times, right? You are saying times. And if you're saying times, that means the whole thing is one term. But if we had x plus y, because the two terms are separated by a plus, then we would have two terms. And also, if it was x minus y, we would still have two terms. So it's very important to understand that really when terms are divided by multiplication, they form one term, okay? But when they're divided by what we call addition or subtraction, then they become multiple terms. But obviously this is division, so this and that, so this is one term, this is also one term, but this whole fraction forms one term. So division and multiplication, they really bring down too many terms into one. I don't know if that makes sense, but anyway, let's get right into it, because just by explaining, I don't think we'll crack it. So let's start solving. So the thing that we're going to do here now is we're just going to start off with this term. So we're going to start with this expression and then that expression, right? So on and so forth. So what we are trying to do is we are trying to factorize. Do you understand? We are trying to factorize so that everything becomes one term over one term. So let's do that. So what I'm going to do is I'm going to say, okay, fine. Let's start off with x squared minus x minus 6. So we need to factorize this. right? So whenever you're thinking one term of one term, think factorization. There's no any other method that you can use to bring these terms to one term. So how do we factorize? This is the easiest type of factorizer. This is a trinomial, right? A trinomial whereby the coefficient of x squared, this expression here, is 1. That's not complicated, all right? So you just put x. Now you need to figure out what numbers are going to go there and there. And really find the numbers, you just focus on the 6. So we're going to say, okay, here's our 6. What are the factors of 6? We've got 2 times 3. We've got 1 times 6. So those are the factors that we have. Now, from the factors here, we need to find a combination that's going to give us -1 when added, but when multiplied, it needs to give us -6. So let's start off with the 2 and the 3. 2 plus 3, that's 5, which is not -1. 2 times 3 is 6, which is not -6. Okay, let's tweak things around now. -2 times 3, that's -6, that's fine. But -2 plus 3 gives us +1, not -1. Then let's try keeping the 2 positive, then make our 3 negative. So 2 times -3, it will give you -6. 2 plus -3, it will give you -1. So this is the pair that we're looking for. If you check 1 and 6, they will never give you -1 as the middle term. Right, yes, they will never give you -1. But as for -6, this one, you can definitely get. But remember, both conditions need to be met. We want to have both. We want to have both the middle term and the constant. Right. So the middle term when we're adding the 2 factors, and then the last term when we're multiplying the 2 factors. So meaning that here we're going to have 2 and 3, negative, positive. So 2 plus 3, -1. 2 times -3, -6. So our factorization is complete. Then let's look at another term, right? Let's look at another term. So now we've got x squared plus x minus 20, which is the denominator there, right? So let's check. So we're going to have x, and then factors of 20, we've got 5 and 4. We've got, what else do we have? 20 and 1. Yes. Right, so we've got x and x. So now the factors of 20, that's 5 and 4. All right, and then 20 and 1. So definitely 5 and 4 will give us, +1 if we, get the signs correctly. So 5 and 4, you can see that 5 minus 4 can give you +1. So +5, -4. And then 5 times -4, it gives you -20. So factorization successful. And then we, this is like the easiest type of factorization. 2x minus 8 is equal to what? So here you can see that there's an x on the left, and then on the right there's no x. So there's no way we can have our x as a common factor. So we're just going to take out 2. You can see that 2 goes into 2 and 2 goes into 8. So that's why I'm taking it out as a common factor. So you really want to be taking out your highest common factor. So x minus what? What do you need to multiply 2 with to get -8? All right, that's -4. So we're done factorizing that. If you multiply everything throughout, you will see you'll get back your 2x minus 8. So let's go back to 2x minus 6. So let's check the highest common factor here. I think it's 2 again. What do you need to multiply your 2 with to get your 2x? That's x. What do you need to multiply your 2 with to get -6? That's -3. So factorization done. And then there's another factor here. Another expression, which is x squared minus 3x minus 10. Which is equal to, so we need to factorize. We're doing the same thing, 2 brackets, x, right? Factors of 10, that's 10 and 1, and 5 and 2. 5 and 2. Okay, then we need to figure out the signs. So in order for us to get the middle term, -5 plus 2, it gives us -3. So -5 plus 2. Okay, -5 times 2, -10. So factorization successful. And then we've got another special type of factorization, which is what we call the difference of 2 squares. Okay, you've got a perfect square here and a perfect square here. I hope you know the perfect square is 1, 4, 16, right, 25, 36, 49, so on and so forth. Those are perfect squares. So now the perfect squares, we know the square root of x squared, that's x. The square root of 25, that's 5. Okay, then you alternate the signs. then done. And if you don't understand what I just did over here, go and do some research about the difference of two squares. Right, so this is the type of factorization that I'm applying here. And once we've done that, then we can go right ahead and substitute everything back into our expression. So we're just going to replace these terms over here with our factorized version of those terms. Okay, remember, from here to there, here it's 1, 2, 3 terms, but on the like on the left hand side, the right hand side, this is one term. Okay, because this and that are glued by multiplication. Of course, within this bracket it's 2 terms. Even within this bracket it's 2 terms, but the whole thing, it's one term. Do you understand? Which is exactly what we're trying to do. All right, make everything to become one term. So let's go back and substitute. So we know that x squared minus x is basically what? X squared minus x is basically this. So let's just do some quick substitutions and see what we get. So we've got x plus 2, x minus 3 divided by x plus 5, x minus 4. We're just replacing everything with what we have, like the factorized versions. So 2x minus 8 becomes what? 2 into x minus 4. And then we also got 2 into x minus 3. Okay, division here. In fact, we need to change division into multiplication. So instead of x squared minus 25 being in the denominator, it's going to be in the numerator. So we're going to have x squared, not x squared, but x minus 5, x plus 5. And instead of having x squared minus 3x minus 10 in the numerator, it's going to be in the denominator. So x minus 5, and then x plus 2. And then this one we're ready to cancel. This is one term, this is one term, this is one term as well, this is one term. All right, so once you're factorized, you're ready to cancel. You can see that x plus 2 is equivalent, is the same as this. So as long as we've got identical terms, one is in the numerator, one is in the denominator, then you can cancel. Okay, but if they are like both in the denominator or in the numerator, then they don't cancel, they multiply each other, and then you sum the exponents. So, and then we've got what? X plus 5. Let's see if we can't find another x plus 5 in the numerator, then we cancel them. There's an x plus 5. And then x minus 3. Let's see if we can't find any x minus 3 in the denominator. Here's another x minus 3. So this and that's the cancel. X minus 4 in the denominator. Let's look for another x minus 4 in the numerator. Okay, so there's x minus 4. They cancel. 2 in the numerator. Let's look for another 2 in the denominator. There. Right? And then x minus 5 in the numerator. Let's look for another x minus 5 in the denominator. Right? So everything is cancelling. So our answer is going to be 1. It's never 0. It's never 0. Right? Unless if the sum of the numerators gives us 0, that's the only time you can get an answer of 0. So that's it, ladies and gentlemen. So if you found it a bit difficult to understand the things that we've been doing here, here's what I would suggest. Go and study factorization. Factorization of trinomials. Right? Factorization of trinomials. And a trinomial we mean ax squared plus bx plus c. This is the type of factorization that you need to focus on. Also, what else can you study? Yeah, I mean that's the most important thing. Yeah. So